Oh man, wouldn't it be nice if I could solar power the chicken coop? It'd be so nice. But you know, I spent a lot of money on things lately, and I should just wait and do it. You know, do it down the road. Just be patient, wait a little bit, and do it down the road. Wrong. Yes, that's correct. I did go out and buy a Goal Zero solar generator. I bought it from the Goal Zero site directly. This is actually an open box unit. It's the Goal Zero Yeti 1000 lithium. I figured it was a way to test out the viability of using solar power to power some things around the property without spending a fortune. Like I said, this is an open box Goal Yeti 1000. It costs roughly $700 or something like that. I'll put a link in the description below. Goal Zero has bigger units. They have a Goal Zero Yeti 1400 and a Goal Zero Yeti 3000, which is a monster solar generator. But when I did some calculations, I'm planning to use this out in the chicken coop area, by the way, and we'll be covering all that. I did some calculations, and based on the amount of electricity used out there, I think I will be fine with a 1000 watt hour battery. So anyways, this is going to be documenting how this whole procedure goes. I plan to hook it up to two Renogy 12 volt 160 watt polycrystalline solar panels wired in parallel. And we're going to mount them out in the chicken coop area. We're going to run the wires up into the coop and hopefully power everything by solar. So we'll see how it goes. So I really like the features on the Goal Zero Yeti. It has a lot of functionality incorporated into a very compact box. Everything is pretty clearly labeled. You have your 110 volt outputs here, two 110 volt outputs, and it's able to sustain the inverter is able to sustain 1500 watts continuous of output, which is pretty impressive, and even up to a 3000 watt surge for, like, you know, some appliances when you start them, they will surge and pull more wattage initially. This can support up to 3000 watts on a surge, which is very, very good. It has outputs for USB. You can directly charge your USB devices here. It has 12 volt outputs as well, and you just control these outputs just by pressing this button to activate those outputs. So you can power, you know, cigarette adapter, 12 volt appliances or other devices, and that comes in handy for sure. It has a conventional plug-in input. You can charge this just off the wall if you want to. You can put multiple chargers in here if you want to. You could plug one in here. You could get a second charge. You can plug it in here. This is an Anderson Power Wall connector. No, Anderson Power Pole connector. I'm sorry. And these inputs here are connected to what they call a PWM input, or PWM controller. And I wish I wrote down what that acronym means, but I do not know off the top of my head. It's a fine controller, but when it comes to solar power, there's another option that works better, which the camera is actually sitting on right now. And that option is called, Goal Zero labels this as the Solar Charging Optimization Module. But what this actually is an MPPT controller, power controller. And this allows for pretty significant increases in charge rates, especially when using solar panels. It seems like it can help anywhere from the neighborhood of 10 to 40% in charge times. So that's always a good thing. And this actually, the MPPT actually just mounts right here, which we'll be doing later. Just mounts right here in the box. And again, just is integrated with everything. Very, very slick design. The box that it came in, you know, looked like a normal brand new box, but it did come with this very important warning, and this is something that I read about as well, that you never are supposed to exceed 22 volts of input from any of these sources combined. And I guess if you do so, you risk overcharging the unit, and it could have all sorts of negative consequences. So what that basically means is my 2 panels are 12-volt panels. With solar panels, you have the option to wire them in series or parallel. When you wire them in series, the voltage amount of each panel adds up. So 2 12-volt panels would be over 22 volts. It would be 24 volts. So it says specifically here, do not connect panels in series, or you could damage the unit. So I will be connecting those 2 12-volt panels in parallel. I'm going to install this MPPT controller. As you can see, when I shoot videos, fashion is very, very important to me. I try to make sure I look as fashionable as possible. But be that as it may, we're going to try to get this installed. So basically, this little cover comes off that I just removed. And I believe these screws here need to come out. Okay, so there's 6 screws. 1, 2, 3, 4, 5, 6. We're just going to take those out, and this will slide in that spot. All right, so those are out. So this should, there we go. The whole thing just slides right out like that. And then down below, you have connection for power, and then this is some sort of data port connection. I don't know if that is involved with when you have the Wi-Fi option for these that's used, but this is a keyed connector, so you can't put it in wrong. So I'm just going to hook up these cables and slide this into place. This data cable is small and not in a great spot. Alright, I think I have that in there. So now these cables just kind of sit down into this channel, and you don't put it in backwards. Just slide in just like that. Right. Looks like it was part of the original unit. So it looks like you only need 4 screws to put back in. Do you need to watch me put screws in? Probably not. They give you 4 longer screws that are used for this. So yeah, the ones that you took out, you can just keep for a rainy day, but you're going to need these longer ones to install the MPPT module. It's installed, nice and tight. This is ready to go. We're going to take this outside. I have my solar panels outside. I'm waiting for some brackets to use to attach it to a frame I'm going to build, but I want to take this outside and just hook some stuff up just to see what kind of numbers we get hooked up to the panels. All right, right now we have the Yeti in the chicken coop. No, this isn't how it's going to be stationed permanently, but for now, just for my testing, I have it hooked up to my equipment, which is a UPS, a DVR, a couple smart switches, 2 fans, a Wi-Fi router. There's an LED light, and there's also some LED Christmas lights that come on at night. And right now it says that it's pulling 8.5 amps, which is, let's see, that's kind of more than I thought it was going to be pulling. All right, 105 watts. Okay, because when I did my testing, I put a kilowatt on here. A kilowatt is a device that you can measure your output. And when I did that, a few weeks ago, it was showing that I was only pulling like 65 watts. So I'm not quite sure why I'm pulling more right now. I still think I'll be fine, but that is interesting. So now what I want to do is I'm going to just hook up one of the panels to the Yeti and see what the numbers look like. Okay, so I have my 20-foot extension cables for now hooked up to one panel. I'm going to attach my adapter cable, the MC4 adapter cable, to the Anderson power pole. I think that's that is the name of this style plug, Anderson power pole. So we're going to go red to red, black to black, and then this just plugs in right here. Like I said, I only have it connected to one panel right now. 160 watt, 12 volt Renogy polycrystalline panel. And you son of a gun, I have the wrong adapter. Damn it! I need a vertical adapter and I have horizontal. Shit. Alright, so I'm not the type that gives up very easy, so just for the heck of it, I went, of course I did this after I went and just ordered the correct one with a vertical stacking. But then I just thought to myself, okay, well this silicone boot just slides off, and these were just stuck together this way, so I just put a screw between them and just pop them apart, and now I can stack them the way that I need. So yeah, I should be able to just stick these in correctly. So let's do that. I might have been making a mountain out of a molehill. I can figure out how they go together. There we go. Alright, so yeah, just take the boot off, snap those apart. Now I'm going to just slide the boot back up. And there you go. I think that'll work. Awesome. I'm not quite sure why I thought that was quite as dire as it was, but it's not. Alright, so we're going to hook up now our two cables, and we're going to see if we get some input. Alright. And we do. See, we got a flashing blue light. And we have 27 watts coming in. Output 7.8 amps, 98 watts. I'm just hitting the buttons here to see what we got. Alright, so yeah, right now we have 26 watts coming in. 7 amps going out. So okay, so that's probably the most relevant one there. 26 watts coming in, 97 watts going out. But it is charging. That's awesome. Now if you look here, it's overcast. And I have the panel not facing up like it was going to be, so let's just make this a little bit more horizontal. All right. But again, the clouds are kind of thick right now, and this is one panel. But if you figure, if I had the second panel hooked up in parallel, all right, that's 30 watts. So if I had the second panel hooked up, we'd be looking at somewhere around 60 watts. I guess I should try that to make sure though, huh? Wire these panels in parallel, you need an adapter like this. Basically, you combine two positives and two negatives, and then you get your outputs. So this would be, okay, it actually says positive on here, so we would be taking our positive off of the panel. I believe is this one. Well, it has to be. It's the only connector that'll fit this. So we'll be positive there. Alright, so right here we have the two negatives combined together, going into a shared output. Okay, here's our positives. Got them combined, and then we're just going to hook them up to the MC4 cable again, the extension cable. Okay, I do have them wired in right, thankfully. As you can see, the input now has been pretty much doubled, 65 watts. Again, with the panels just thrown out there haphazardly and cloudy skies. So when I first plugged this in, it said that the time to empty was like 10 hours. Now it's showing 22 hours. And you might recall me mentioning the kilowatt. This is what the kilowatt looks like. This is what I use to estimate how much power was being used by the Coop equipment out here. So yeah, if you're looking to do something similar, this is a very handy tool. Just got some direct sun out. Again, with the panels not pointing at an optimal angle, we now are at a plus as far as wattage. Input's right around 100 watts. So, and that's basically how I'm hoping it's going to work. During the day, it's going to have enough power to run everything strictly from solar, with additional going into the battery to recharge it based on whatever is used overnight will be replenished. So that is the hope. Now I just have to figure out what I want to do about the mounting spot for these panels. My plan was I was going to use this spare fence post here and plant it in the ground here and then build my frame and just have the panels here. The disadvantage of that is obviously I have to then get the cables, the MC4 cables, into the coop. And the only way to do that practically is I would have to like make a little trench and bury them. Which I've done with lots of different kind of cables before, so it probably wouldn't be a huge deal. Definitely more labor though to do it that way. And but the other option I'm thinking about is building a frame similar to, you know, like what I've done here, and just having it right here on the ground, and then I'd be able to easily route the wires in through that window. So I have to think about that. I'm not sure which way I want to go, but that's all for today. All right, so no, I didn't film every step by step because it took long enough as is. So I did not want to you know, add 30 or 40% to the amount of time that this project took. So what I decided to do, I was a little back and forth on what I was going to do with the panels, but I came up with mounting them on this corner here. It's twofold. It gives me something very sturdy to attach to. You know, these corner posts are in quite deep and they're thick, and it also gives the chickens some additional shade. So that's what we came up with. I have the 260 watt panels mounted here on a frame made out of pressure treated 2x4s. Have mounting hardware that I bought off Amazon. I'm gonna list and then just in the video description any parts that I did buy for this. So what I did is I had a spare fence post, so I sunk that fence post, mounted it to the center, attached it to the center, and then I also dropped these 4x4s in either corner. These are not into the ground, these are just to ground level, just to give support for the actual stand. This is very, very solid now. I probably could jump on it if I wanted to. So that is the actual support for the panels. Underneath, I do need to get some more zip ties so I can tie this up a little bit better. But there I have my T adapters, my 2-in-1 adapters that connect to my MC4 40-foot extension cable. That again is going to be tie wrapped better to that post, goes down into the ground. Goes into the ground. I put that little irrigation tubing around there at the bottom so when I weed whack and stuff I'm not going to hit the wires. And then I used my little hand edger and I dug a little seam in the ground that comes over to here. Goes underneath the border stones, comes up there, goes in here where I already have other wiring going into the coop. I need some more stuff to clean this up a little bit. I'll route these in a nicer way, but for now it's working. Into the window, I built this stand just for the Yeti, made out of 4x4s and more pressure treated lumber. Very, very sturdy. And it kept, I was going to put the Yeti in that corner, but I didn't have quite enough cable to reach that far. And this way I didn't have to move anything else in the coop. You know, everything can stay where it is. So it's up off the ground, nice and high. We're going to have to obviously stay on top of this as far as keeping the dust off because it gets very dusty in here, unfortunately. So I think we'll be doing that a lot. But yeah, it's hooked up. The MC4 cable goes to my Anderson power pole adapter cable, and you can see it is charging. And it's 17 watts right now. It's overcast and it's about 6:15, so we're not getting very much sun at all right now. So I'm not hooking the load up to this yet. I want to get a full day's sun on here, and then I will try it, and then we'll have to see how it goes if the Yeti is able to power everything that we have here overnight until we get sun again. So that will be a little bit of experimentation. But everything is working. Now, like I said, only 16 watts of power coming in, but it's going to be very interesting when those panels get full sun, because they are 160 watt panels. I'm very curious what the max I will see as far as input goes on this Yeti. It's a fun experiment. Even if it doesn't work 100%, it's fun, and it gives me other ideas that I might be able to do something similar in other areas of the house in the future. So, like I said, that's it for now. I will be doing a follow-up report to let you know how this is actually working in Dalen. Oh, the rooster's just trying to cause trouble everywhere. I'll report back and let you know how this actually works in practice once I hook a load up to it and see if it performs as I hope. Hopefully it does. If you found this video interesting, please give it a big thumbs up. If this is your first time visiting the channel, Dalen! Hey! Dalen! Get off! You get off! Go! No! All right, that's what it sounds like when you yell at a rooster that's attacking and pinning down a hen. Even though it is a natural thing, he's on one of the adult hens, and I don't know, I just didn't like it, as you can tell. So anyways, that's all I have for you for now. Until next time, Duffman out. Calm down, big boy. You better calm down. I'm the big rooster around here.